Here we have a SAT math work problem based on triangles. Okay, let's go over the question. Dawson needs to measure the height of a building near his house. He chooses a point P on the ground where he can visually align the roof of his car with the edge of the building roof. The height of the car is 4 feet and the distance from point P to point Q is 10 feet as shown in the figure above. If the distance from point Q to point R is 80 feet and the height of the building is K feet, what is the value of K? Okay, here it is given the height of the car is given that is 4 feet and the distance from point P to point Q is 10 feet and the distance from point Q to point R is 8 feet and the height of the building is K. So we have to find the value of K. That means we have to find the height of the building. Okay, let me draw another figure connected to this one. Here I have drawn another figure connected to the information over here. Okay, so here QT represents the height of the car and S represents the height of the building. So actually the height of the building is K, is given in the question, and I just marked the given measures over here, here. Okay, now, so consider the two triangles over here, that is PRS and another triangle is PQT. Okay, here for these two triangles, P is a common angle for the bigger triangle PRS and for the smaller triangle PQT. So let me take the vertex P in the bigger triangle and the smaller triangle as well. Okay, now so here the angle measured Q is right angle, the angle measured R is also right angle. So clearly the two angles of the bigger triangle, I mean the P and R, are congruent to the two angle measures in the smaller triangle, that is P and Q, because P is a common angle, Q and R are right angles. So the two angles P, R are congruent to, I mean the two angle measures P and R in the bigger triangle are congruent to the two angle measures P and Q in the smaller triangles, because P is the common angle and R and Q are the right angles. So whenever two angle measures of one triangle are congruent to two angle measures of another triangle, then the two triangles are said to be similar by angle similarity postulate. Okay, so now let me write the vertices of the bigger triangle. So I've taken the vertex P in the bigger triangle first. It's over here. Again I'm taking the same angle measure P, the smaller triangle P, and now I'm going to take the right angle in the bigger triangle R. Now let's take the right angle in the smaller triangle, that is Q. Okay, now in the bigger triangle, the third vertex is S, and in the smaller triangle, the third vertex is T. So these two triangles are similar. Okay, whenever two triangles are similar, the corresponding sides must be proportional. Okay, here my aim is to find the value of K, which represents the length of RS. RS, okay, first let me take the side RS in the bigger triangle. What is the corresponding side in the smaller triangle? So here RS is the second letter and third letter over here. So to get the corresponding side in the smaller triangle, take the letters at the same position. It is QT. QT is the corresponding side for RS. So RS divided by QT. Okay. Now let me take another side in the bigger triangle for which I know the length. So in the bigger triangle, I know the length for the side PR. So I am taking side PR. The corresponding side in the smaller triangle is what? So here P and R, the first letter and second letter. So to get the corresponding side, we have to consider letters at the same positions. P, Q. Okay, so for RS, we know its length is K. And for QT, we know its length is 4. And for PR, we know that length 90. And for PQ, we know that it's 10. So 10 goes into 10 one times, 10 goes into 90 9 times. So I get K over 4 equals to 9. So to get the value of K, I need to multiply both sides by 4. So this 4 will cancel out. I get K equals to 9 times 4 is 36. So the height of the building is 36 feet. That is the value of K is 36.